So good afternoon, everyone, and welcome. My name is Alexi Westcott. Thank you for joining us today for the session of our Building Bridges Community of Practice Lunch and Learn. This is one of many regular events that we will be hosting here. So if you enjoy it, keep an eye out for the Building Bridges community and what's next, so that we can regularly grow and learn together. I would like to begin our time together by acknowledging and respecting the First Nations, Métis, and Inuit peoples of whose traditional territories use work is conducted across Canada. We strive for respect, relationships with all Indigenous peoples as we search for collective healing, true reconciliation, and honoring these beautiful lands and seas together. And I'd like to acknowledge that currently I am in Nova Scotia, which is the traditionally Mi'kmaq. And before we get started, I have a few housekeeping items to highlight. So after Arun's presentation, we have a question and answer session. So if you'd like to ask questions verbally at that time, you can raise your hand and I can turn on your microphone, so you can do it that way. But if not, you're welcome to add questions during the entire presentation in the question and answer box, or in the chat box. So either way. So to find the question and answer box, you go to the bottom of your screen and it may be hidden under three dots, the three dot menu, and then open that up and you find it. For best experience, we recommend that you joining through a web browser to make sure, or that if your app is up to date, to make sure that you'll be able to find the question and answer box. So during the whole session, feel free to use the chat to connect with myself or other attendees. If you run into any issues, just let me know in the chat box. I'll try to help. Please note that the session today is being recorded and will be shared on our YouTube channel and on the community platform, the Building Bridges platform, as a public resource. So today, I'd like to introduce our speaker. Arun Biju is Associate Researcher at Nova Scotia Community College. He has a strong background in structural analysis, spatial data processing, and database management. And today he'll be sharing the presentation Beyond the Cloud, Building Secure, Cost-Effective Solutions with Local AI. And now I'm pleased to turn the mic over to Arun, and you can go ahead anytime now with your presentation and sharing your screen.
Hello, everybody. I hope you can hear me. Can somebody please confirm it?
I can definitely hear you. We'll see if we also hear from the chat.
Yeah, I see a few hands up. So I'm gonna start sharing my screen. So share. Hope you guys can see this as well.
Yes, looks good.
Hello, everybody. I'm Arun. I work as a researcher here at the NSCC campus. And then I also founded an online startup. And what we do is we, help small businesses and, organizations get transition into AI and, help with apps and everything. So in this, presentation, we'll be diving into looking at local AI and then how we can use local AI to do a lot of processing and how to decouple from, cloud-based APIs and then all of that online paid services, which would give us, security, and it would bring down our cost. And then, you'll get more control over it. So I'll be focusing on these three main areas, which are very important. And then I think not a lot of people are worried because they're okay with using AI however they like it, but it shouldn't be treated that way. So let's start. So I'm gonna assume that a lot of people, are not familiar with what AI is, what LLM is, and what's training, what's inference. So before we dive into any of those, I'm gonna give some, I'm gonna explain some of those terms. First of all, artificial intelligence, AI. So our AI is not a new thing. We've always used AI for like decades. At first it was just recognizing patterns, and then it was used to detect all sorts of changes, and like small changes, and then it was used to detect, improve workflow basically. But at some point, we started learning that, hey, training a even larger data set and then letting it learn our human language would be beneficial, because these models can process large amounts of data, and then it can help us uh, you know uh, do stuff beyond just recognizing patterns, or improving our workflows. So at some point we started using a regression model. A regression model is basically an AI model that predicts each word, and then based on our input, it can generate a response. So it's pretty much we're asking a model a question, and then we get a response back, and then that response is based on our input. So if we train a model, and then if we give it a lot of information, and then at some point we ask questions about it, it can give you responses and then insights into the data that we trained it. So whenever you hear AI now, it's mostly a large language model, and it's trained by large corporate companies or sometimes even governments, because these AI models helps us, do things faster, more efficiently. So there's a good interest in, like, for companies and governments to train a model and then set workflows using these. So what does training mean? So training means the way we send in informations to a model. So when we send them documents, when we send them languages, we're letting it learn languages. We're sending them audio files. All sorts of digital data can be ingested by these models, and then they build their own neural network within them. So it's called deep learning, and then the model learns on its own how to connect those dots. And then when we ask it questions, those same dots are matched, and it kind of figures out, hey, this person is talking about this topic, so we should look into those areas. So in a similar way, you train a model, and then inference is another term that you might come across during language models and AI. So that's what happens when you send a model what do you call, a prompt or a question. It does inference. It means it's going through its neural networks, it's going through its deeper network, and then trying to identify, hey, what does this question mean, and where does the answer align, where does something that's connected to this question align, so that the model can process it and then give it an output. So both of these terms are going to be really important, because they kind of decide how much a model is going to be in terms of cost, and then how much time it's going to process something, because the speed of the models, effectiveness, and then all of that stuff depends on training and inference. The more data you give, the better the models at understanding stuff, and the more powerful the computer is, the faster it can inference, means it can process the output. So these terms will be used for benchmarking and comparing different models. Now, earlier, when large language models were introduced, there were just regular chatbots. We could only ask questions, and then you get replies. Sometimes the model give you wrong answers. They're not perfect, but we're trying to, with each iteration, it's getting better. But we're at a point where the models can, do good reasoning. That means it can decide if it should go in one way or the other way, and then it's good enough that it can pick up common logic, and then it can decide on, like, if you should do either of those. So we're moving towards using those what you call reasoning capabilities to build agents. And agent is like so we'll discuss what an agent is further along, but just as an introduction, it will be like an autonomous way of using this LLM's reasoning capability to perform activities. So since this is more about a local deployment and how we can use AI within our local environment, we'll be discussing on how this open source model is different from a closed monopoly. For example, a closed monopoly, they are a business, and they want to try and make money out of it. So what they do is, when they train a model, they spend billions or millions of dollars into data centers, and then collecting information and all of that process, and they spend huge amount of money, resources like water and all of that stuff, to cool the data centers, so for months. So what they do is, they take up all these resources, and they do this for like months and months, and then at some point they're gonna do retraining, and it's a lengthy process and really expensive. So they've got a huge bill. And then their business model is, hey, if we're spending all this money, then we need to somehow recoup it and make a profit out of it. So what they do is, once the model is trained, they send out this model's capability as an API or a way for customers to access. And what they do is they pay for each request, so they get money back by talking to the model and sending information back and forth. And there's a trade-off and what do you call a downside to this. The downside is that you're relying on a third party to do all of this processing, and then you're relying on their cost metrics. So if say for some reason a big revolution happened and we found out a way to bring down the cost of electricity down, but it's still up to the company to decide on how much they're going to bring down the cost of training. So if we become super reliant on a specific model or a specific company, they decide on how much the pricing is going to change. So that's why it's a monopoly. On the other end, on the other spectrum, we've got open source, companies and governments trying to train models. So what is their benefits? So being open source and limited on money, most of them rely on tricks and ways to make the training part more efficient. And there are instances where certain open source models came super close to a really premium model. So one example was DeepSeek. DeepSeek is a Chinese company that they trained a model that was capable that had similar capability to a GPT-4. So GPT-4 is like a model that's from another proprietary company called OpenAI. I'm not sure if you guys have heard about it, but they're a company. And then these models, once they're trained, they can simply be downloaded by anyone, and then they can use to fine tune it or change its parameters to make it work in a better way for our business needs or whatever need that we've got. So we've got the option to completely download it and use it however we want. So how do these companies make money? So there are companies, that train these models, and they bet on the fact that when they release an open source model, they get a good, they get research from people who are fine tuning it. So when they get an open model, like I said, we can open it and we can train it. So when we train it, you get a specific model for a specific task, and that's done by somebody outside of your environment. So you're pretty much getting researchers and specialists working on your model, fine tuning it or adapting it to a specific task. And at some point you'll have multiple versions, doing multiple use cases. So you get free labor and people who are interested in doing it to fine tune your model, and you can pretty much use that model to build up APIs and then run them on your own server and send it to others. So another thing they do is they offer the infrastructure for hosting these models. So inference part, when you ask a question to a model and then the model responses, it's called inference, and this inference part takes up hardware and resources. So sometimes they lend out hardware online, like digitally, and then you can upload your model there and then do the processing and get the output. So that's another way of them making money. And then another example would be to build products that uses these language models. For example, one big example is Meta. What they do is they've got smart glasses and all of that stuff, and they use AI to detect images and people and all of those sort of stuff. So they released an open source model, and what that did is it gave them if it hadn't released an open source model, you would have to rely on a paid a model from another company. What that would have done is it would have brought up the cost for whatever products that Meta is selling and whatever products or whatever stuff that you're going to use AI for. So since they've got their own open source model, they can use that, and then they can get cheaper inference by letting others host it. Even if they're not hosting it, they can get services from others. So what I'm trying to say is, there's the way the open source models work is it's betting that we might be able to somehow recoup the money by selling it as a service or by selling other products. And then it's also trying to carve into the paid market by forcing people to, at some point switch to an open source model because of the advantages like price and privacy, which we will be diving into. Now, this is like a simple example on like how much some of these recent models would cost. So the numbers here means it's in US dollars, and GPT 5.5 is like a model that's from OpenAI, and Mythos 5 that's from Claude, and Gemini is from Google. Qwen and DeepSeek, they're both open source, the one in red, and you can see how much of a difference there is of output. So when you send them a message, like when you send the model a request, the model gives you some response back. So the response, most of the time, it's the output cost that's higher because that's where you do inference, and then that's where you do, all of those complex tasks. So that's the most expensive part of a request. So if simply looking at these, you can already see the advantage of open source models because it's way cheaper because they're openly available, and there are like multiple providers giving you access to this API, and you can and like all of us know, competition drives price down. So this is like an example I wanted to show, like why it is, why open source model exists and why we need it. Now, so you can rely on these third parties, their hardware to host these models, and we can send them a request, and then they give us response back. This solves one problem, that is cost, because multiple providers would give you multiple access, and then like I said, demand brings down what do you call, more suppliers means less price. But the problem with that is you still have to send this data to their servers to process, and we have to really trust them. So what does it take to really host this on our own premises? Like how much does it cost for us to run our own models? So there are like 3 different tiers that I would say that can be used to host a model depending on your organization size and then what you're trying to achieve. So the first would be like an enterprise server. So this uses like really expensive hardware, but it also gives you good what you call inference time. It processes everything super fast. So you can use NVIDIA. NVIDIA is like a leading player in terms of hardware, and there are hardwares that are like here in this instance it costs close to 40,000 per GPU. It's a GPU is like a processing unit that processes all of this AI stuff, and then there are older versions of similar hardware, and they're also really expensive, close to 25,000. So this might not be an option for all the organizations, and especially for smaller ones. But for a corporate, this might still be useful because they're only paying for the hardware. For using a model, you're not really paying. So it's still beneficial if you're a super large organization and you wanted to adapt AI into your system. So the second option would be it's a recent release. So there are local AI running machines, and one of them is like recently released by NVIDIA. It's called an RTX Spark. Now the price range is close to 5,000 US dollars, and what this does is it'll help you run a model, pretty capable model, within your local system, and then you can send in information and all that, processing requests and all of that stuff into this machine, and this machine would process it and send it to you, which means you're not really talking outside of your network. You don't even need internet access if that's what you want. So this is another option, and it's very new, and then people are trying to use it. And one of the most common way people used to do it, and it's still a very common way, that's how we'll be doing a live demo today, is to use your own personal computers. So if you're able to get access to say a Mac Studio or like a computer with a beefy graphics card, it's still expensive. But if you compare the long-term cost, especially if you're a nonprofit organization or like any organization, it'd be hard to justify paying a monthly fee of say $500 or $200 for API than buying hardware which you can use for years to come. So if you're looking for grants and stuff, it'd be really hard to justify, hey, we need this much dollars every month for maintaining this app or maintaining this infrastructure. But if you buy a hardware, even though it's a little expensive, it would make up, in the long run. So this is still a great option. So it's a regular consumer grade compute systems like regular desktop PCs or like a Mac Studio, which can be used to run AI. And from all of these slides, you might have seen they're all specifying a RAM and VRAM in it. And AI really needs a lot of memory to run. So it's processing all of this information and storing it inside VRAM. And VRAM is really fast at like moving stuff around. So we need that fast, imagine it as like a highway. We need the highway to be super wide for everything to go back and forth. So VRAM is like in really good demand. And then that's what really determines how much or how big of a model we can host in a machine. So with this system, like a local system, we can host a model, a pretty capable model that can handle, almost, I'm going to say 60, 70% of the workload. And then if there are more workload, we can send that to an API or, sort of stuff that are not that sensitive. Now that we covered the hardware that we might need and the price estimation we might need for an organization, let's look into why we need local AI. Why not just send it to an API? So I might have briefly discussed this, but privacy is one of the biggest concern for a lot of organization, especially if you're dealing with something that's really sensitive, and you have to send in information to a cloud that's not from your country. So there's lots of tension in this world right now with geopolitics and everything, and so anybody can turn any of their technology off at any point. And then they can also, even though they say, do you really trust government and policies? Because there is nothing stopping them from simply acknowledging and saying that they're going to do this, and to the exact opposite thing. So it's really hard, and especially if you're sending IP or sensitive data, you have to trusting somebody over it. It's not something that we should be doing. So that's why we're looking into open source models and ways to connect it to our own local server. So how does open source models and how does this work? So what this does is, when you have your own server, you host your own model inside it, and then you've got a computer or like or data inside your computer. When what you do is you send this locally, using a local network to your AI processor, and then it processes everything, and then you get the output back. And then what it does is, you can do this in a closed environment, meaning that you won't need to connect it to any network, and this would simply make sure that everything is secured and within a closed loop. So you have full control over it, and then nobody can turn it off, and nobody can say, hey, we're gonna limit this or whatever, right? Now, this is the other part. You own the intelligence. So once you have everything set up, you have it for however long you want to run it. So all you have to do is provide power to it. Now, even providing power to it, it comes to that point that I said earlier. So if you found out a way to make your power run more efficiently, so if you decided to go with fully solar or you get more renewable energy, you can simply tap into that and then, take advantage of, maybe running this thing for like really cents and like pennies, right? So that is the advantage. You own the intelligence and you own whatever you fine tuned or whatever you change the model. So you can really adapt it and then keep it as your own stuff. You don't have to rely on others. Now we know what I hope you know what large language model and AI is, how inferencing matters, and how sending data back and forth matters, privacy and all that stuff. We now know that we've got a capable intelligence that can be hosted online or hosted on-premise. And then now what do we do with this? So I briefly talked about AI agents, and what an AI agent does is it takes the reasoning capability of a model, and then it gives it instructions, and then access to tools, which would give the large language models a way to explore and then look at our data and then process data and then give us insights. So an agent is like an autonomous way of controlling a large language model. So a large language model looks at some stuff. Our AI looks at our data and then what a request is, and then it uses tools to get the job done. So it is self-aware, and it's not self-aware. It knows it's got something called as a memory stored. So most systems got a memory inside it, so it knows what it's doing and what its task is. So once you give it an instruction, it'll follow a specific what do you call a channel, and then do certain tasks in an order, and then at the end it'll hopefully achieve our goal. It's not 100% guaranteed, but it depends on what kind of model we're using, how capable the model is, which all goes down to how the model was trained, how much data was provided to it, what kind of training technique was used to train the model. So it depends on a lot of factors, but for the most part, like for like small jobs, or for not even like small jobs, but jobs that are really large and like mundane, or that needs a lot of repetition, it can easily be handled by these AI agents. So it'll automatically do all of that stuff. It'll identify what needs to be done, and it'll do all of that stuff, and then come up with a result, hopefully at the end. Now, so that's what an agent is. So it is like a digital employee, and it does stuff for you. So if you own it, you can use it for free, or if the power is free, it's pretty much free. So that's how you do it. Now, for any agent to be really good, it needs to do three things. The first is reasoning and planning, and then second one is tool use, and then the third one is reflection and memory. So this is like a capability that all of these frontier models, or the really expensive models, are trying to perfect. So we've come a long way. So even frontier models that are paid and open source, they're really good at reasoning and picking a choice and then deciding which tool to use, and then marking its progress somewhere, and staying on track. Sometimes models do something called a hallucination. What that means is it takes in so much information, and then it doesn't remember what was doing, and then it automatically does something random. So a reflection or a memory on like how the system is made will keep making sure that this model is staying on track. Or sometimes it's a simple way of like splitting the job into multiple small steps, and then making the AI do it in like baby steps, basically. So it really depends on the model capability and what kind of system you're using for the model. So model is simply way of like digesting and like giving output. So the more tools you give it, the more access, the more you know uh, stuff you give to it, the more it can use all of that and then come up with a better solution and a better answer. Now, we all of us know that having an AI, an autonomous agent, do stuff for you in the background, or when you're sleeping, or when you're short of hands for some stuff, is really useful. So we can really already, like large companies and like big companies are switching to integrating AI for a lot of tasks, like workflow automation, which means you can do an entire, for a company or like a business, it can go through an entire process of talking to a customer, getting an order from a customer, fixing a customer's complaints, and in a way that the company's what you call policies and their standards are met. So each agent can be given its own identity. So if that agent is programmed for a company, we can make sure that all of the replies and all of those messages and back and forth between a customer is in compliance with whatever the company wants. So it's pretty much like a digital employee, and then it can do automation. It can do all of that stuff, whatever a regular employee can do, but not all of them. But it's getting up there, so it's getting pretty close to what can be done. And then we're already starting to see people lose jobs for like small people who are doing like regular office jobs. It's really sad to see, but it is happening. And enterprises, they're all about money and making profit. So what they do is they simply cut jobs and then use AI agents. But there's another spectrum to it. So when you're a nonprofit and when you're really struggling for doing stuff, and you're really tight on budget, then these extra hands would be useful. So one example would be to you going through a document and then getting insights from the document, or talking to people, reaching out to people, or getting recent information, news, and then keeping track of let's say the latest updates on a certain project. All of that stuff can be done by agents, and this saves time and money and effort for companies or small organizations that need it. Now, that's what this slide pretty much says. So it'll help them scale, and it'll help them reach that target without having to break their bank. Now, OpenClaw is an AI agent system. So a large language model, or an AI, is the brain, is the reasoning part of any agentic system, and OpenClaw is like the software that uses that brain to do processing. And OpenClaw is open source, and it's really uh, more of a, what do you call, a party trick at this point, because it can do a lot of stuff and it's really easy to do. But if you're going to use OpenClaw, then you need to make sure you do a lot of guardrails and all of that stuff. There's a lot of setup you need to be doing. So we won't be diving into any of those setup or anything. We'll be just what I'll be doing is I'll be just showing you what the potential is. So how OpenClaw does this processing, and how OpenClaw talks to a large language model, and how instructions are passed and all of that stuff. So OpenClaw is open source, like I said, and it's a hobby project. So if you're trying to actually build products, I recommend doing custom web applications and stuff, and custom endpoints and all of that, to make sure that you've got a bigger control. But OpenClaw is the fastest way to get started, and then start doing stuff. So it's so easy to set up that almost anyone can do it, and it's like I said, you get all the advantage of it being a local, it being private, and you get access to cheap. The cost also is also down. Now, how does OpenClaw work? So OpenClaw is like a software that runs on your computer, and then what you do is you connect a large language model to the OpenClaw, and then OpenClaw's got all of the systems. So earlier we mentioned that an AI agent needs a good memory, or a good way to reflect on what it did. So OpenClaw provides that system to this, what you call, large language models, to say, hey, for doing a process, you have access to these tools, and you can store your memory here, you can reflect on what you did here. So it gives the system to the large language model, and the large language model uses it to perform tasks. And then you get features like trying to check if the system's online. If the system's not online, OpenClaw will automatically bring in your model, it'll automatically load it into your memory. So it'll do a lot of system checks and system updates, and tasks that you would otherwise manually have to do it. But this is all automated, and then you've got lots of support for communities building a lot of apps and skills and features the large language models can use. And then once it's built, you can simply import it, and then use it with your workflow. So that you have to be really careful, because you need to be really sure on what you're bringing into the system, especially if you're dealing with sensitive stuff, because OpenClaw is not really like I said, it's more of a party trick right now. And then there are much better alternatives, and then much better options to actually do it. So you have to really know what you're giving access. So giving a large language model hands and features and tools, and letting it run wild, is not something that we want. We need to make sure everything's controlled, and there's guardrails in place. And then if it's dealing with sensitive information, we need to make sure there's a human in the loop or something like that. We need to ensure all of that stuff. So we won't be diving into any of those today. I'm sorry, but it's a really long process, and it would take a lot of time. And since it's just a small session, and we need to go through a quick, I don't know, question answer session. But I might not be doing that. But just be aware that we need to set it up, and that there are other options like building custom application. That's the way to go. It's a similar thing, but instead of OpenClaw giving all the tools, we custom design tools, and then guardrails for whatever task we're doing. Now, how does OpenClaw do stuff? So this is an example of some of the stuff that OpenClaw does. So shell execution. So shell execution means it can run commands on your computer to copy files, move files, read files, and then file system access. The same thing, you can delete file, create file, and run commands on it. And then it can do browser control, meaning it can do if you're doing click tasks, you can automate that. And sometimes you can use this to read stuff off the browser. So a lot of automation. So anything you can think about that's repetitive work, we can use OpenClaw. And then other agentic ways to automate it. Now we'll be doing a live demo according to that part. And what I use for this live demo is a laptop, and my laptop's got like a 24 GB VRAM. So that's the memory where this model is going to be loaded onto. And then if the model is larger than what we're about to load, it'll spill out and it'll go into a regular memory. So there's two kinds of memory. There's one is the graphics card memory, the GPU memory, and then there's like a regular memory. So all of this is what I'm trying to say is there's like a place where you need to keep the model so that the highway is open, that it's wide enough for message to go back and forth. And then there's two kinds of road, and that one is fast and the other one is a little slow. So sometimes if the model is super large, we just can combine the road and put it anyway. So running the model is better than not running the model at all. So that's the idea. So this is my system, and so we'll be using a model called Qwen 3.6, and it's released by a company called Alibaba, and they're Chinese, but they're open source. So we've got all the research paper, and everyone's auditing it, and it's secure, and we don't have to really worry about it. So we'll dive into a demo on like how an agent can do what is OpenClaw, and like let's visually see what all of this stuff is. So I'm just going to end my presentation there. OpenClaw. So this is like a web interface for OpenClaw. So where you ask questions. So anybody who's ever used ChatGPT or Gemini or whatever, you know what this is. So you can type in messages and then you get answers. So you get activity and you get all that metrics that you need. So OpenClaw can technically be connected to closed source models. And so OpenClaw has a way for us to, look at pricing and usages for whatever sessions we're doing and how much whatever stuff we're doing. So, it's a full system that lets you go all the way from, setting a model up and then, looking at all the insights on how much you're spending, how much is the model's accuracy, how often are we doing the same request over and over again, how often is the request failing. All of that stuff can be seen here, and you can see skills and what all stuff the OpenClaw can do. Now, I've got pre-recorded videos. So since this is my GPU, my local system, so since we're using a cloud, Qwen 3.6, it's at the very, edge of my system's capability. So if I run the model like live right now, it might crash my presentation. So what I did is I recorded a session of it processing the documents, what do you call the live demo. So before I show that to you guys, let me show you what we're going to do here. So let's just say that we're a human, a place where people talk about human rights, and then we get or human rights activist group or like an organization where we look at people's input, and then we send a caseworker, and they go there, they take in their information, and then they write down logs. So we've got like hundreds of logs, depending on what kind of where we end up being and who we talk to. We might have like hundreds of people and lots of notes to go through. So in this example, it is really sensitive, and we shouldn't be sending this information to a cloud, and then we don't want to rely them. So we can simply copy all of this data and paste it in ChatGPT and like ask for the same response. You pretty much get, it'll filter all of that stuff out, and it'll answer your question. But that's not what we want, because this is a sensitive piece of information, and we need to make sure that the system stays within our network. So in this case, we've got like lots of field notes for subjects and their so another thing that I need to mention is that all of these are like synthetic. This is generated by AI. This is not a real account of anything, and these documents are going to be sent to our local model, and the model will process it. Now, how do we do it? So what we do is we pretty much go to OpenClaw, to the chat window here, and then we give it instructions. So I'm going to give it in a minute. See, we're giving it clear instruction on like what needs to do. So we're saying read the contents of the field nodes batch1.txt file. So that's a file that's stored here, and we're going to get some insight from it. So we go here and we're saying scan the casework and extract only entries involving women or children. So mentions of minors, toddlers, pediatric, all of that stuff that's really relating to children. So AI is good at reasoning. So this is the reasoning part of the large language model. So it can identify based on those words, or it knows to detect stuff. So it knows how to reason and pick it. And then we're gonna say that, hey, do not add all of our sensitive information to the report, and then give us a final report and like what you found out. That's the initial request. So another thing to watch out for. So you're really programming an AI's reasoning here. So earlier you needed to have an in-house programmer to do something like this, right? So right now you're just using plain English to program reasoning into your model. So it's the same thing, but you're using regular English, and then you're letting large language model handle the programming and all of that stuff that's needed to get this task achieved. And as you can see, it's running on a Quen model. And then once you give it that prompt, what it will do is it'll send in this request to our local like the machine. So the model is running within the machine. So the way it's run is it's using something called as LM Studio. In my case, there are lots of ways you can host a model. So what it's doing is it's sending this information to the model, and the model is actually assessing what the request is. So it's doing inference. So this is a step where the model spends consumes a lot of power. So that's why when we looked at the pricing chart, that's why it was that's why that's where what do you call these companies charge money. That's how they make money of it. So this is that step, and we're performing this inference on our local computer. So I'm just gonna run it without any speed up. It'll only take 2 minutes, so just bear with me. I just wanted to show this so that you get a realistic expectation of how long it would take to process a document like this. So if you had given this to, say, a paid model or like a Google or a Gemini, like a DeepSeek, or not a DeepSeek, I mean, ChatGPT, you would have gotten your result or your output by now. But also note that this is running on like a regular computer. Like this is not a special. It's an expensive PC, but it's not a specialized hardware that is, designed to run this. So right now you can see that it read and wrote something. It used 2 tools. So within OpenClaw, there are tools, and then it processed everything, and then it brought down some what do you call insights. And here you can see that out of those, it figured out 1, 2, 3, 4, 5, 6 cases, and they're all related to female and then child. And then it also gave us extra and let us know that these cases were about with gender M and then a non-binary case. So all of this was taken out, and then it wrote a report, and this report was returned to this directory. And if you open up that report, so this is that report right here, and you get a report like for each case, what's being done here. Now we can simply use this and send it to another person who needs to know what these are without sending them actual, sensitive information. So this was done on like for 10 or 20 cases, and it took us 2 minutes. But if we had hundreds or thousands or a lot more documents or papers to go through, we can run this in a loop, and it will automatically do all of those inferencing, and it'll give you an output at the end. So any kind of document and any kind of place where we need autonomy, we can use this. So that is about it for my live demo. And if you guys have questions now, I'm gonna stop sharing my screen. And if you guys have any question or input.
Thank you. Thank you so much, Arun. It was a very insightful talk, and it was very helpful for a better understanding of building and using AI, large language models, and accomplishing that potentially locally. And I really appreciate your discussion of the paid versus the open source potential. So, like you said, yeah, we have time now for question and answer. If anyone would like to either put a question into the question box or into the chat, let us know. I don't see any right now, so I do have a question for you. And also, if someone wants to put up their hand before I ask my question, I can unmute you and let you speak, anybody in the audience, if you prefer to do that rather than write out your question. So I'm wondering your thoughts. Maybe you did talk about this a little bit, but just thinking kind of about the slide that you had, the paid option of using AI and large language models versus accomplishing that locally, investing in local hardware to accomplish it. And I was just wondering what your thoughts are on the accessibility of that. So, like the pros versus cons when you think about, well, accessing something that's sort of made for you and you're paying per use versus building something yourself, accomplishing it yourself for a specific reason. And I'm just wondering about the accessibility of that. So where it could be a major pro in how much it costs, you also might need to have a certain level of experience or like school knowledge or, studying about the different ways of doing things. So I'm just wondering, how big of a jump do you think it is in learning for someone to know what they need to know to set it up to have it work as well as what it would be to just go ahead and pay for it?
Yes, so we're still talking about open source versus closed, right?
Mm-hmm. Yes.
Yeah. So with the closed source model, there are a lot more, help from those companies for training and fine tuning a model. But with open source, you still get a lot of community guidelines and experts. So if you're planning about doing it on your own, you might still have to go through a little bit of learning process, and you really need certain hardware to do it. So training a model still requires some expert to do it, but the real advantage is the way when you start doing it, when you think about privacy and then cost. So that's the biggest place where the open source market wins. So if you're looking for reliability or like maybe even speed, closed source models are still the way to go. But if you're more into cost and then privacy, open source is the way to go. And you should always uh, and the barrier to training, it's still a little high, but I feel like if you spend enough time, you should be able to do it on your own. You even with maybe a little bit of technical knowledge, you should be able to.
And do you think with, say, government institutions or academic institutions like universities, do you think there's more of a push currently, or do you think it's much of a discussion currently to have it locally for that privacy issue or the cost discussion, or do you think that that's not necessarily a directive right now?
It is a really big topic right now because if you look at all these large all closed source models, they're all US based. And then a lot of these open source models that are competing with them are Chinese. So you can really see that, there's like big governments involved in like training these models and like, trying to, I'd argue that each government is trying to come up with its own solution and trying to overturn the other ones. So if somebody's going for a paid model and then we're going to release a free version that's going to carve at their, so they're spending hundreds of billions of dollars in training it. And if you release a product that's similar to them for free, all of those money spent by them are going down the drain because people are going to use the free version. So it's trying to, there's lots of politics involved in it. And in terms of academics and then, people wanting to do it, yes, there's always a push for it, but the limitation is it still is that hardware. So hardware that's used to train this and then, come up with fine tuning and all that stuff, it's really expensive. And then we're still catching up to manufacturing where we're way what you call behind on manufacturing. Like hardware that's required to train these models are like booked up for like years. So it'll be years until these manufacturers, build up or expand their facilities and these prices go down. Maybe that's when it'll be more accessible to academic institution at least. But for smaller tasks, it's still, doable. We still do it. And then you get good results, especially if you're doing something really specific.
Okay, I still don't see questions coming from the audience, but I did have another thought of a question. And it's kind
Okay.
of around the agentic. Oh, no, I just see one here. I'll ask this one first to make sure that we have time to answer questions from the audience. Um, so the question here in the question box says, do these models retain memory between versions? For instance, we start ON 3.7 and in a year 3.8 is out. Does the new model have to learn everything from scratch, or is it compatible with the memory 3.7 already made?
Yeah. So there's two distinct uh distinction between a memory and like training data that it acquired. So when a model is trained, we feed it information, and all that information, even if a newer model releases, the old model would retain it because it's using the same training data set and one extra year worth of data for the newer model. So technically, if you ask it who was the president of Canada in like whatever yada yada year, it would give you the same answer. It means it preserved that insight during training. But let's say if you're doing a task on your OpenClaw or like a ChatGPT, that memory is temporary and it's using something called as retrieval augmented generation. What it pretty much is that whatever you're typing or whatever you're asking it, it's saved in a local folder. And then when you're talking about it, it's sent in every time during inference. So it's being sent to the model every time. So memory during training, like whatever it learned during training, it retains. And obviously when you go from an older year to a newer year, it should technically retain it. But sometimes when the model does not, during training, if the training is bad enough, it won't save all of that information. Then they might get lost. But anything that's stored what using a memory or your browser like inside a file that is sent in during inference, it'll be preserved across these models.
Okay, right. That makes sense to me. You can, it says anonymous attendee. So if you need a follow up, send that in. But I think I understood your answer quite well. Thank you. I was just wondering around ethics around the agentic AIs, and when you kind
Mm,
of liken them to an employee, I can see how some employees might not, at some companies, physical people might not need to use like make ethical judgments necessarily all the
mm,
time if it's a very sort of like consecutive
yes.
work progress that they have, but other employees actually need to have use nuance, sort of social various social cues and sort of ethical considerations where there might be rules that
Mm,
they have to manage, but giving them a technical list of rules might not be enough to effectively answer a question or help guide a client. So I'm just wondering if you've,
mm.
I know that's a little bit outside the scope of what you've been talking to, but not exactly, where if you've heard of instances where it's just not working out um, very well in certain cases. Like, do
Yes.
you know of certain cases where they really probably aren't the best? I mean, obviously, there's some jobs that they won't be able to do, but ones where we might think that they'd be potentially able to do a good job, but they're just not able to yet.
So right now, what the industry is doing is it's set a guardrail for all of this ethics-based work. So it doesn't want the model to answer or do reasoning on any of those questions. So what they do is if it detects something like this is happening, it'll simply let the user know that, hey, I'm not qualified or I might not be able to make the decision because of all of that constraints that the model might have. So earlier models used to do it, and then they made some bad decisions. For example, if for some reason it needs to pick between a homeless person who's in need of a lot of assistance and between another family, or somebody who needed more money or same amount of money. So there's only like little amount of money within it. So it can really, if you pick one, the other one is going to be a problem. So we need to assess, we need to have more information on like what to do and like how to, move forward from here. So like I said, it's the ethics part is still, we still need somebody in charge, like a human in loop part, we still need it. And then using it as an employee and consulting it in that way, it's still up there. We haven't come up with a proper solution yet, but keeping a human in the loop is still what we do.
Hmm. Yeah, I guess I was thinking of where you said there's sort of the guardrails or the hard stops, and they have to say no, I won't answer. And then we also talk about the hallucination. So I wonder if sometimes they might hallucinate that they actually are able to answer. But it sounds like that they can get that like hard stop to prevent
Yes.
that. Okay. Okay,
Yeah.
thank you. So I don't actually see any more questions, and we're just before the half hour, 1:30. So if there's anything else that you'd like to add about yourself or your talk, otherwise we can, I'll just do the closing with a few comments in the closing here.
Yeah. Oh, that's pretty much it. And then, if you guys need any help setting up AI automation, or if you need help figuring out a system, I'm always I'm available. So you can email me at admin@maritimedigitech.com, and then I'm available there. That's it.
Okay, yep, and maybe we can make sure that there's a way for, well, I think there is, but we'll make sure that there's that information inside the community too, so people
Yes.
can circle back there and find your contact if they need to. So I just wanted to thank everyone for their participation today, especially our presenter, and a quick reminder to stay connected through our upcoming community offerings. So we'll have regular AI clinics, our next meetup event, and our learning session on August 4th is the next one. And that's about building and using intelligent data exploring assistants. They are all free, and we'd love to see you there. So all of the sessions I'm talking about, the AI clinics, the learning sessions like we had today, are all free. The next upcoming session is the link to sign up is in the chat box. And so finally, I'd just like to extend our thanks to all of our partners and funders for the Building Bridges project. So the Ocean Supercluster, the Department of Fisheries Oceans Canada, and Meopar for their support and making this initiative possible.